Hey guys, today we're going to talk about the intersections between straight lines and parabolas. So before we jump into it, let's just remind ourselves that there's three possible outcomes. If we graph a parabola and a line on the same axes, there could be zero solutions, one solution, or two solutions. And so the reason we should kind of mention that is because when we looked at the quadratic formula and we looked at the discriminant for the quadratic formula, we could use the discriminant to determine the number of intersection points of the parabola and the x-axis. In other words, the discriminant told us how many roots the parabola had, whether it was 0, 1, or 2. And we determined that based on the discriminant being less than 0, equal to 0, or greater than 0. So when we're looking at not the intersection between a parabola and the x-axis, but a parabola and just any straight line, we can use that same logic basically to determine the number of intersections between a parabola and a straight line. All right, so enough of that. Let's look at this set of examples here. Notice we've got a parabola and we've got a straight line. So if I wanted to solve these equations simultaneously, that means I'd be looking for values of x and y that satisfy both these equations. And to solve it, I would just substitute equation 1 into equation 2. So I see that the value of y given to me in equation 1 is x squared. I'm just going to take that, substitute it into equation 2. So x squared is equal to 2x. Subtracting 2x from both sides, we get x squared take 2x is equal to 0. I'm just going to... so before we go any further, let me just back up a little bit here. So what we're saying x squared is equal to 2x. So we're saying this quadratic is equal to this straight line. So what that means is, what are the values of x where this quadratic is the same value of x as this straight line, basically, right? So we're looking at the values of x where these two guys are intersecting, right? Because we set them equal to each other, so we're looking at their intersection points right now. So I'm just going to solve this for their intersection points by subtracting 2x from both sides. Gives me kind of a quadratic, which we know how to solve. Factor out x to get x take 2 is equal to 0. And using the null factor law here, I can see that x has got to be 0 or x has got to be positive 2. Alright, and if I go ahead and substitute these values of x into either one of my equations above, I'll see that, well, if I take 0 and put it into equation 2, y is equal to 2 times 0, we're going to have y is equal to 0. So there's an intersection point at the origin, 0, 0, and there's an intersection point when x is equal to 2, so 2 times 2 when y is 4. So we're going to have two intersection points, right? When x is 0 and x is 2, and the corresponding y values we found by just substituting x back into any of those equations. So what we have, well, y is equal to x squared. That just looks something like this. And we have a straight line, y is equal to 2x. That looks something like that. Intersection here at the origin. And there's an intersection here at about 2, 4. Alright, let's look at another one. So y is equal to negative 4x squared, take x plus 6. Y is equal to 3x plus 7. Again, I'm just going to take equation 1 sorry, and substitute it into equation 2. So we'll have 3x plus 7 is equal to negative 4x squared, take x plus 6. Now I'm just going to take everything over to one side. So we'll, again, it's worth mentioning, we're saying this line is equal to this parabola. So that means we're talking about the points of intersection, right? So when I go ahead and take everything on the left hand side over to the right hand side, so negative 4x squared, take x, take 3x, right? And then plus 6, take 7. When I take everything over to the left hand side, it looks like a quadratic, but it's not talking about the intersection points. Or if we set, because this is 0 on the left hand side instead of like y, for example. So when we set this left hand side equal to 0, it's not talking about y is equal to 0. We're saying this line is equal to 0. So we're looking, when we sort of set this up with the quadratic formula, we're looking for the points of intersection when the parabola meets the line, not the x-axis. Anyways, that's enough of me rambling. Let's keep going. Sorry. Negative 4x squared, take 4x, take 1. And yeah, so let's just chuck this straight into the quadratic formula, right? Because it's a quadratic equal to 0, so we'll say x is going to be equal to negative b, so that's 4 plus or minus square root of b squared, that's going to be 16, take 4 times a, so 4 times negative, well, let's just write it all out, deal with it later, negative 4 times c over 2a, so that's going to be 2 times negative 4. Okay, so we're going to have x is equal to 4 plus minus 16 subtract. So negative 4 times negative 4 is positive 16 times, alright, so that's going to be take 16. So we can see that this discriminant is going to be equal to 0. That's going to be over negative 8. And so we only have one solution. It's going to be 4 over negative 8. In other words, negative a half. So if I graph out these equations, whatever it might look like, we'll see that we have one intersection point between them when x is negative a half and when y is not true. Let's just get this done on the calculator. Well, actually, it'll be half of 3 is 1.5, so negative 1.5 plus 7, so 6 is 5.5. So it's going to be about 5.5. So we have this coordinate points here. 0.5 and 5.5. Okay, but let me erase that so I got room for this last one here. Okay, one more. Y is equal to x squared plus 1 and 2x take 3y is equal to 4. Alright, so same idea, except the one difference is we don't have, y is equal to something here. What I still can do though is just take my value of y that I'm given in my first equation and just substitute it in where I see it in my second equation. So that's going to say something like this: 2x take 3. Remember, y, 3 times y, where y is x squared plus 1, that's going to be 3 times x squared plus 1. So I've got to remember to put brackets around that, and that's going to be equal to negative 4. So from here, we'll just do the same thing. We'll just get it all over one side, set it equal to 0, and solve it like it's a quadratic, when in actual fact, we're looking at the intersection points between a parabola and a straight line. And I might just add 4 over to this side while I'm at it. Okay, so we'll have negative 3x squared, 2x, take 3, oh yeah, no, that's it, so plus 2x, and that's going to be plus 1 is equal to 0. Again, just some quadratic equal to 0. We can just plug this straight into the quadratic formula because it's almost as if we're looking for roots, but remember this is an equation. Sorry, this is because we've put these two equations together, the parabola and the line. We're looking for the intersection between the two, the parabola and the line. So it's not actually looking for roots; it's looking for intersections between parabola and a straight line. But I think I've prattled on about that enough. Hey, so negative b is going to be minus 2 plus or minus the square root of b squared plus minus 4ac over 2a. So negative 2 plus or minus square root of 4 plus 12 over negative 6. So x is going to be equal to positive 1/3 actually, plus or minus 4 plus 12, that's 16, so it's going to be 4 over negative 6, or that's 2/3, so plus or minus negative 2/3. So in other words, minus plus 2/3. Wrap your head around that one. Okay, so we got two intersection points here because our discriminant is greater than 0, so we got to find them both, unfortunately. So first, let's just get these x values a bit more neat. 1/3 take 2/3, that's going to be negative 1/3. And 1/3 plus 2/3, that's going to be 1. So we've got two values of x. Let me make this a bit more clear. And so the values of y we could find, I'm going to substitute them into the quadratic here. So y is going to be equal to negative 1/3 squared plus 1. That's equal to positive 1 on 9 plus 9 on 9. So that is equal to 10/9. So we have one intersection point at negative 1/3 and 10/9. And the other one, y is going to be equal to 1 squared plus 1 is going to be equal to 2. So we have another, when x is 1 and y is 2. Cool. So if you want to try some, here you go. You can pause here and have a look at these. But yeah, that's about it. Cheers.